Hello everyone, myself Sandesh Godavi, studying in Sri Venkateshwara College of Engineering, Bangalore, the Department of Information Science and Engineering. Today, let us start the video. Today, the contents are mutation analysis in fault-based testing, steps in mutation analysis, fault-based testing adequacy criteria, types of fault-based adequacy criteria, benefits of fault-based adequacy criteria, and conclusion. And let's start the contents. First of all, we have to know what is mutation analysis. Mutation analysis is a powerful technique used in software testing to evaluate the effectiveness of test suites. It involves introducing small changes known as mutations into the code under test and then rerunning the test suites. The mutations are designed to stimulate faults in the code, and the goals of the analysis is to determine how well this test suite is able to detect test faults. In software testing, there are some criteria how the code will be tested. So, like that only, the mutation analysis is also one of the criteria. In this is the one of the powerful technique that is used in software testing. So, effectiveness of two test suites, so small codes will test in this. It involves introducing small changes known as mutations. While running the code, if anything, the small changes that are done that are known as mutations. Mutations analysis in fault-based testing. Fault-based testing is a technique used to design test cases that are specially treated at detecting faults in the code. So, fault-based testing is a technique that is used to designed for testing the cases that specially targeted at the detecting faults in the code. Mutation analysis is a natural fit for fault-based testing because uh, it allows us to stimulate these faults and evaluate the effectiveness of the test suites in detecting them. By introducing mutations into the code, we can evaluate how well the test suites it is able to distinguish between correct and incorrect behavior. So whatever the small changes we made in the code, right, the mutations, that helps us to evaluate how well this test suite is able to distinguish between the correct and incorrect behavior. Steps involved in mutation analysis. The following are the key steps involved in the mutation analysis. One is selecting a mutation framework. In this selecting mutation framework, there are several mutation framework available for different programs like such as PLT for Java, JavaScript, and for Python, etc. So like that, we have to select a framework and generating mutations. What are how to generate mutations in the JavaScript, Python. So that is the second step. Once the mutation framework is selected, we can generate mutations using the frameworks, using the frameworks. So once after the selecting framework, the mutation framework is selected. Uh, Once the mutation framework is selected, we can generate mutations using the frameworks. The mutations are typically introduced by making small changes to the code. Such changes as a Boolean condition, swapping the order of statement, modifying a variable. So as I told pastly, mutations are the small code that we small changes made in the code. So that are the mutations. The mutations making small changes in the code such as like Boolean conditions and swapping order of statements and some modifying their variables. So that are called mutations that makes a small change in the code. Running the test suites after generating the mutations, we rerun the test suites to evaluate how well it detects the mutations. The test suites should ideally detect all the mutations since the represents faults in the code. So we only introduce that mutations, right, by changing the small piece of code in the code. So whenever we rerun the code, that has to detect differentiate how well the code is detected before introducing the introducing the mutations, how the code was running, and after introducing the mutations, how the code will run. So that is the major difference here after rerunning the code. Next, analyzing the result. Finally, we analyze the result of the mutation analysis to determine the effectiveness of the test suites in detecting faults. We can calculate metrics such as mutation score, which represents the percentage of mutations that were detected by the test suites. Next, fault-based adequacy criteria. Fault-based adequacy criteria are used in software testing to evaluate the effectiveness of test suites in detecting faults. The idea behind this criteria is to design test cases that are likely to reveal faults in the code based on an understanding of common type of faults and the code structure. So this is also as same as the mutations adequacy, how we introduce mutations, right? Like that only. This is also a fault-based adequacy criteria, the software testing to evaluate the effectiveness of test suites. How effective, so whenever we introduce mutations, right, how effective that test suites will detect the faults, that is the one of the fault-based adequacy criteria. So the idea behind this criteria is to design the test cases that likely to reveal faults in the code, and based on understanding of common types of faults and the code structure. Types of fault-based adequacy criteria. There are several types of fault-based adequacy criteria, including statement coverage. Statement coverage is this criteria requires that each statement in the code is executed at least once during the test suites. So statement coverage is how the compiler will check right line by line code. So like that only, here also we have to make sure that the each statement in the code has to be executed at least once during the test suites in a simple and widely used criteria. It's a simple and widely used criteria, but it may not be sufficient to detect all faults. Next, branch coverage. This criteria requires that all branches in the code is executed at least once during the test suite. It is more comprehensive than statement coverage, but it may still not be sufficient to detect all the faults. Next type is condition coverage. This criteria requires that each Boolean condition in the code is evaluated to both true or false at least once during the test phase. So condition coverage is like matlab, how to say, for example, take if else statement only. We will give one if statement. If that is true, what is inside that statement that will be executed, or else next statement, right? That only the Boolean conditions, that one, it may be true or it may be false. So that Boolean condition is has to be executed during the test suites. It is more comprehensive than branch coverage, but it may still not be sufficient to detect all faults. Multiple condition coverage. This criteria requires that each combination of Boolean condition in the code is evaluated at least once during the test suite. It is more comprehensive than condition coverage, but it may be difficult to achieve in practice. Path coverage. This criteria requires that each possible path through the code is executed at least once during the test suite. It, It is the most comprehensive criteria, but it may be effective or very difficult to achieve it practically for complex code. For complex code, like we have more number of lines in code, means the path coverage is very difficult. We can't go depth inside the code, so it will be difficult to achieve in practical. But in software, it it, it does it so easily. But in practical way, we can't what we can't uh, identify the path where what happening in the code. So that's the complex thing here. Next, benefits of fault-based adequacy criteria. They provide a rigorous evaluation of the effectiveness of the test suites in detecting faults. They can help identify gaps in the test suites that needs to be addressed to improve fault detection. So this is also one of the advantages in fault-based adequacy, where we have given more gap in test codes that small things will be identified, and we can still improve the code and fault detection in the fault-based adequacy criteria. They can help prioritize test case based on their effectiveness in detecting faults. They can help reduce the cost of testing by identifying redundant or ineffective test cases. Next, so we have came conclusions on mutations and fault-based test adequacy criteria. Mutations analysis is a powerful technique for evaluating the effective of the test versus in detecting faults. So next, fault-based adequacy criteria is a powerful tool for software testing. Mutation is a small piece of change what we are done in the code, where fault-based testing is a tool for software testing to test the code, right? So providing a comprehensive and rigorous approach to the evaluating the effectiveness of test suites in detecting faults. While each criteria has its strength and limitations, using a combination of criteria can help in ensure a high level of default or, default detection and minimize the risk of software failure. Yes, this is the end of this slide. Uh, Thank you. If you like my video, please like and subscribe. Thank you.